Hello everyone, I'm José Cruz, I'm an enterprise architect and welcome to my channel. Today I'll be teaching you how to develop a time-based one-time password. This means that we will be developing a very simple client that will simulate, or a real simulator about how to develop an authenticator like Google Authenticator or Microsoft Authenticator, and of course a server that will generate a kind of a secret that I'll explain in a moment why, and can generate also these numbers. So you can sync them and you make sure that both can generate the same number for a specific person, which means that you can authenticate like Google Authenticator or Microsoft Authenticator and even others do it. So let's see how to do it. So first, what is a TOTP? But basically stands for time-based one-time password, and it's a foundational component of two-factor authentication, meaning that nowadays, for security reasons, only the username and password aren't enough. You need a second factor, something that you should have, something like an object that that should belong only to you, not only about what you know, but additional for something that you have. Because someone can steal your password, but stealing your password and an object for you, even a two-factor authentication like a Google Authenticator, Microsoft Authenticator, it will be difficult. Stealing the both at the same time on the same session in a few seconds, it's really difficult. And that's why critical systems, when you access to the cloud, banks, accounts, and things like that, usually require two-factor authentication. So at the end of the day, you should know a password and you should have an authenticator all the time on your mobile or close to you. So how does it work? Usually, these systems, they generate a number every number of seconds that you define. Usually, most of the applications define 30 seconds, but you can configure to 60 seconds or any other time. But usually 30 seconds, it's enough for a human to read, go to the server, go to a specific web page and write this, or even in other type of servers. That's why they choose 30 seconds. There is no another reason to put more time on this. And by the way, if you extend this time, let's say 2 or 3 minutes, it means that someone that knows your password can try to steal your session. Because if it takes 2 or 3 minutes and someone looks into your authenticator and you are taking a longer time to apply this number on the server, someone can go ahead of you and use it. That's one of the reasons that we choose 30 seconds for this type of two-factor authentication. So it is important. It makes the access safer and secure. So you have a stronger authentication because it's two types of authentication at the same time. It's resistant to phishing, and it follows an open standard. It's user-friendly. Everyone understands the number and how to write it in a server. Okay, where is it used? Where usually you have sensible information that you want to make sure that is really difficult to access, like banking accounts, financial services, corporate and enterprise systems, and so on, GitHubs, where the projects reside, and things like that. That's where do you want to use this. So let's see the algorithm. So usually you can read this, you can pause and try to read this, but I will explain in simple terms. So you need a shared secret. Why shared secret? Shared, it's between the authenticator application and the server application. So somehow you have to create a secret, and you can generate one by yourself, or you can use a library to generate a secret, because you only need to generate this secret once. Meaning that at the end of the day, what will happen is that you have the server and you ask the server, okay, please generate a secret, and then it will display to you a kind of a QR code with additional information that you'll see in a moment. And you have to find a way to take this secret and push it to the Authenticator application, and usually it is used a QR code, but it can be something that you write. For instance, if it's not possible to use a QR code, you can write something or maybe send in another way. But at the end of the day, it's a secret that will be stored in two places at the same time. One is in the server and the other on the Authenticator application. And of course, it should be linked to time, because that's the only way you can sync a server with something that you want. Otherwise, it will be crazy. How can you generate something that have the same value in two different systems besides the time. There is no way to do this. So you need to find a way to use the time. Of course, now it's what is the best granularity of time. It cannot be a second, because if you generate a number in 1 second, next second will be another number. So it will be very difficult as a human to go to the other place and write the number. So you should split this time in specific slice. And usually it's use 30 seconds, but you can use any other granularity. Imagine that to simplify the language, we start today the count. So at midnight, the first 30 seconds will be the number 1. The second 30 seconds will be the number 2, and so on and so on. Of course, these systems, they use the current Unix time and they divide it in blocks of 30 seconds or any other value that you choose and give you a number. And that's it. So now you have a secret and you have a number, not the time. So when you have this time, so we'll play with both and we'll generate, and we'll see in a moment how a specific number that both Authenticator and the server can generate and be the same. Okay, so the main core of the security will be on this secret, because the security will be different for every person or every system, but the time counter will be the same. So be careful, you cannot share this secret besides the server and the Authenticator. So that's the first part of the algorithm, is how to understand it. Now the second part, there are a lot of details here, but it's quite simple, and you will see in a moment why. So the first thing that you do, you take the time counter, the sliced one, and you convert to 8-byte big Endian integer. So that will be a message. Let's say a regular message. It's like you want to send a document to someplace, but here it's just the time. Remember, that's the number generated. If you go back, it will be a number something like this. Okay. After your slide, now you have a shared secret that was generated, and that will work as a key for an hash function. That's how it works. And now you apply the common algorithm used in signatures. I'm using this one, the simple. There are stronger ones. I just want to explain the algorithm. So it will be quite simple. So you take the key, which is the shared secret. Let's call it password to simplify. Let's say our password, it's password. The word, it's a really bad one, but let's say it's like something like that. Now you should do an iPad. iPad is just to make sure that they always fit the same number of bytes when you are, so everything is aligned. Imagine that you want 20 bytes and you have 8 bytes and you need 12 bytes for the shared secret. So I want to make sure that independently of the secret that you choose, it always contains the same size. So everything is predictable. So you take the secret, let's say this is the secret here on the left, and now you have the message. The message, the time, let's say number 3. So we have you want to take the password, concatenate with the number 3, and you apply the hash and you receive the first hash, H1 here. Now you do the same thing. You take again your secret, let's say password, you concatenate with this hash and you hash it again. And then now you have the 20-byte cryptographic hash value. And that will be the base for this algorithm. So let's say it's on the image on the right side, you can see something like this. Okay. So now what can we do with these 20 bytes? So we go to these 20 bytes here and we want to extract 4 bytes. And these 4 bytes will provide us the number that you want. So how to make sure that you can randomize somehow this? So the first thing is we have 20 bytes and to extract 4. So the first thing that we will say, okay, remember that it's between 0 and 20. So we go to the last 4 bits of the hash. So this number, let's say we go to the 5 bits here of this hash and we take them. And this will give us an offset of the byte where you want to start. Imagine that you had 20 bytes and the 4 last bits is the number 4, which means that we'll start on the 4th byte and we extract 4 bytes. It's a kind of extracting some random number, but we all follow straight this algorithm. Okay, so this is to make sure that the result is treated as a positive integer, and for that, because we want everything to be predictable, here we always put the first bit as 0. So remember, again, I will explain a moment again the steps, but you have this 20 byte size. You go to the last 4 bits. This will give you a number between 0 and 15. If you think for a while, they are 4 bits. And now, since you have 20 bytes, you can choose any position between 0 and 15 on these bytes. And you can always extract 4. Even on the 15, you can extract the 15, 16, 17, and 19. So you can always extract 4 bytes. And now you have these 4 bytes, and these 4 bytes will define the number that you will see on the authenticator. So how does it work? We'll take this 32-bit integer and we just do a mod, okay, a model here for 10 digits. So you make sure that you extract 6-digit code. And if the number we extract doesn't have 6 digits, we path on the left with zeros. And that's it. Okay, that's the only thing that you have to do. And this is the behind the scenes algorithm used for this kind of thing. So let's do a summary so you can understand. It seems complicated if you go into details, but it's not. So first you need a time counter, meaning that you take the Unix time and you split it in blocks of 30. At the end of the day, you just divide by 30 or by 60. Of course, it's more than that because you want seconds and the time probably it's in milliseconds. So you have to arrange somehow, or you can just use a math function, but you take a number that corresponds to a slot of the 30 seconds or 60 seconds, whatever you choose. Now, of course, you have to generate a secret, and now you compute the hash with your secret and the counter that you have. Okay, and this will give you 20 bytes. Now, for these 20 bytes, you want to extract 4 bytes. And where to extract them? It is the first 4, the last 4. Nope, we go to the last 4 bits. We take the number between 0 and 15 because they are 4 bits, if you think for a while, and then we take this as the starting position to extract these 4 bytes. And this will define 4 bytes, which is 32 bits. So we make sure that this number is always positive, and you apply a model and you format to make sure that you extract only 6 digits. If the 6 digits are lesser than 6 digits, because maybe it's just the number 3, we put on the left leading zeros to make sure that you always have the 6 digits. And the algorithm, it is as simple as this. So now we understand the algorithm. Now we have to understand, okay, so how these components work together to make sure that the shared secret is not shared with anyone else, or no other person can guess the secret. So imagine that you are a user and you want to access a server, and the server requires you to use an authenticator. So what you do is that you initiate the setup, and usually you go to the server, and the server will generate the secret key. You don't have to see it. It's a random one, and it will assign to a specific user later. So then we will encode something that is called OTP Authry. I will generate one here for you to see, but I will not be using it. Of course, I didn't design here a GUI to show you this, but I will generate one if you want to use it. And then it will generate a QR code image based on this URI, which contains all the information necessary for the authenticator. So now on the client browser, it will display the QR code, and here you can scan with your authenticator of choice. It doesn't matter which one exists because there is no communication. It's not necessary to create a communication between the authenticator and the server. That's one of the beauties of this algorithm. Now on your authenticator app, it decodes this URI here, and this URI usually contains the secret and other information that should be enough for the authenticator to generate to apply the algorithm the same way that the server will apply it later. So it stores the secret key like the server is storing. So the secret will exist in both server and authenticator, and it starts to generate in TOTP codes. That's why when you open your authenticator, it's always generating every 30 seconds a new number, tung, tung, constantly. Okay, and of course there are other ways to manually to enter the secret if it's not possible to use the QR code. So that's how it works. It's quite simple to understand. Okay, I have explained it here into more detail if you want, but that's the same thing on the design. You can just pause here and say, okay, initiate the setup, the server generates the secret, the server generates the QR code, the client displays it. Probably already did this in the past if you are using at least once the TOTP with your servers and applications. Okay, you can pause here and read, but the path or the flow, it's the one that I explained. Here you just have more details if you want to read it. So this is how it works. And before showing the demo, let's just summarize what we talk about. So TOTP is a robust two-factor authentication method because it's based on a shared secret and time. That's 2 components. And if you understand the purpose of each one, it's quite simple to understand then the algorithm and how it works. Okay, it enhances security, and we understand why, because we have 2 things. One is the password, the other one, it is this one. It involves cryptographic hashing. Usually there are modern ones and using this version 1 to hash. There are other ones, but this one is quite simple to use. Okay, and of course TOTP is widely adopted across critical online accounts, financial service, enterprise. Every time you have a place where the information is sensible, you should enrich your authentication with TOTP. So it's usually we can say it's the cornerstone of modern digital authentications. You see it everywhere. It's quite modern. It's something that it's not becoming outdated. It's quite strong because you can use a device with you that contains an additional secret that even you don't know about it. If you look into the flow again, you don't have to know what is the secret. You just have to have a number to connect with the server, which is quite nice because someone cannot steal from you something that you don't know. And I think that makes this method quite strong because of that. So, but let's see this working. So I prepare here a demo. By the way, this code is shared on GitHub. You can find it. You can find it there. Usually, I post on my channel. There's a section called posts. Usually, I put there the code. If it's not there, please send me a comment, and I will provide you right away. But I will try even to put on the description of this video. I hope I won't forget because I didn't write yet the description of this video while I'm recording it. So let's see the server. So first, this will simulate the server. Let's say a website like Azure or other ones, or even let's say AWS or your bank that usually requires for you the TOTP. So what we need, let's go to the main. So I have here a method where you register a user, and you can see here a call. Imagine that we have the server running and you do a register and you provide your email. I'm calling user one, but you can put an email. It doesn't matter, just a key to associate the secret because you have to generate a secret. Okay. So here, and then we have the verify. This is this one. Imagine that now you have an authenticator and generate a number, and we want to call the server with who you are and the number that is being generated, and it should verify if that's right or not. Meaning that you have an authenticator generating the codes. You have a server that also can generate the codes, all of them based on the secret, and they should be in sync and it should work. So this is our server. If we want to, can go through the code quite fast. This is just a REST API with register and verify. It's just the validation for the port, making sure that the server is running. It's something from Go. It's the usual stuff in any language. So this is the register handler. You can see this is the method associated with this API. So this is just a validation to make sure that we accept options or posts. But the thing that we want is this register request. So we receive here and we decode the JSON. Here you can see here JSON decoder, and which means that we'll decode only this JSON here. Okay, and you can see that this struct, it's above this code here. I can go here. So if you later want to explore all the structs that I'm using on JSON day here, and you can see in Go we can define a kind of a struct, and you can even put rules about formats where we will be using this struct. In this case, I will say that the JSON here, it's the username. Okay, so let's return to our code, register handler, which is our function that handles the registration, meaning that we are starting the process for this QR code. We check if the username that with the code that it's not empty. If it's not empty, of course, it's we don't accept it. But if it's not empty, we generate the TOTP. I'm using a library here. I didn't implement the algorithm. You can implement just a library here in Go. You can see here, if you are using another language, it should be simple. Probably already have also a library that you can use. At least I know a lot of different frameworks in different language that implemented TOTP. So here there are some parameters that you should pass. The issuer, the account name, which will be our user. Okay, the size of the secret, we are choosing 20 bytes. The number of digits that you want on the output. The period, here I will say 30 seconds. I want to generate for 30 seconds, and the algorithm that you want to use. You can change this from the things that we said, and at this time you should understand what all these values mean from the previous explanation. Now we imagine that we have a database. This is just an hash map where I'm putting the username contains this secret. This is our very strong place to hide our secret. Of course, in a real production environment, you don't put here. It works in memory. Maybe you put in a database, and probably you want to apply a secret over this secret. So even if someone accesses your database, cannot see the secrets. Okay, and then we'll display on the output what we generated, because you will need this secret for our authenticator that I'll show you in a moment, this authenticator working. And now we respond with a message here, the username, just something for the output, the secret that was generated, because we will need this secret for the authenticator, okay, and the key. We will not be using this, but in a real production environment, you need this URL. This URL, usually it's encoded for the QR code, and it's the address that the Authenticator application can read and extract the values. In our case, we will write ourselves the secret, but usually from the QR code, that can be done automatically. So we will see this on the output, okay? Then later, so now everything is registered, we have the secret, so we will be providing the secret to the authenticator, and after we provide this the secret authenticator, which will be this client, I will show you in a moment, then we want to verify, meaning when we want to connect to our server, imagine you want to create a call address, show me the movements or transaction on my bank account. So first you have to verify, and for the verify, you need to receive the user and the code that is being generated, which will be our client, our authenticator. Okay, but the server has to validate that. Now remember that the server already knows about your secret. So again, when you receive the user, again, and the code, what should you do? You have to generate first the code, and you want to compare with this code. This code is not necessary to it works like a kind of a password that changes every 30 seconds. That's the beauty of this TOTP. So here we make sure that you are really receiving username and password. This code is similar to the first one. This is just a JSON decoder. Make sure that it's a post here, and that's it. So now what we do is just we get the secret that we have on our very strong hidden database for this username, and we verify. So we pass we verify. Now this is a validation to say, okay, it's not here, we verify. So here we verify the response. I will show you in a moment how it works. If it's valid, okay, great, you can access my API. In our case, I will be just displaying a message output. You can do it. Otherwise, sorry, but you cannot access this because maybe you are trying to hack our server. Okay, the verification here, the verified TOTP, here you can see the only thing that it does, it's to validate. And again, I'm using the library. I pass the code, I pass the secret, the time is quite important to be in sync between both the authenticator and the server. And now, how do I want to validate? And you can see here that I'm using 30 seconds because I defined the secret for 30 seconds. And there is this particular attribute that it's quite important that usually you see in some framework that's called skew. And the main purpose of the skew is, imagine that one of the challenges, you have 30 seconds, but imagine that you are on the boundary between switching from one slot 30 seconds to the next one, and most of the time it failed. If you put here a skew of 1, it means that even after on the second slot, you can still use the previous slot. Usually between machines, maybe this is not necessary, but sometimes for a human, it can be necessary. Even on machines, I once asked myself if I could use this algorithm to protect, let's say, a public client that where the user doesn't log in, but I want to protect somehow my APIs. And if I could hide the secret on my client application and on the server, I could use this algorithm not for a person, but to validate the calls to the APIs. And I remember that to avoid, let's say, fails when trying to request the APIs, I put the skew at 1. Meaning that if the call was on the 0 or 1 second of the next slot, I still use the first one, maybe two seconds to reach the server. And I didn't want for the API to fail. So I would say generate numbers every 30 seconds, but the next slot still accepts the previous one. So it's like the server keeps two different codes at the same time and can validate both. That can be quite handy in some scenarios. Here, of course, we say I want the 6-digit, that's the validation I'm using, and the algorithm. So somehow this validation should be in sync with the one that when we generated here the secret. Okay, this is our server. From the client point of view, we just need to provide the secret, something like this that was generated by the server. This client here, it will be our authenticator. So we have to provide the secret, and it will start to generate the numbers constantly. And then we take this number and we try to access the server. Okay, there is the only relation between the authenticator, this client, and the server, which is a different application. It's the secret they share, because the time should be in sync. And then the validation, it's the same. I'm using the same library. It's not necessary to be the same library. Maybe you have a server in, let's say, Spring Boot, and your client in Android, Java, Kotlin, for instance, or any other one, or iOS maybe. And it's not necessary to be the same framework, only the same algorithm with the same parameters, of course. So here again, if I have a skew or not on when to generate the numbers, again, digit 6 and this algorithm, and that's it. It's a very simple one. The only thing is just to accept the secret code and starts to apply the algorithm and generate in cycle. You can see here on the 4, every second it will generate a new number. So let's see this working. So I already start here the server. You can see it. I just wrote here, go run server. You can do the same way. Okay, and now I will call the API. So imagine that we are on our application, and this for user 1, I will send a request. And you can see here on the response, the message, this is username, and this is the string that we need. This is the shared secret that it's always unique when we call the server. This is the address. Probably if you want to use a real authenticator, this is the one that you need, and maybe you can put this in a QR code. That's how it works. In our case, we'll be doing it manually. Okay, so now I take this, I move here to the client application. Okay, and now I'll do, maybe I have already here. It's not this one. It was a previous attempt. So this is a secret, and when I click it, you can see it will generate a different code every 30 seconds. You can see here the number. It will be the same for the same number of seconds. So if I take this number and do a copy, and now I will verify, meaning that we'll send the user and this code, and I'll do the send request. You can see that, okay, it's okay. The verification was successful. So thank you for watching, and I hope to see you on my next video.